Good morning. The topic of our article is intellectual analysis for Ukrainian refugees number dynamics depending on ethnic frequency from Russian Federation. Presented by Viktoriia Yakovlieva and Sofiia Ivaniv, students of the ISM department at Lviv Polytechnic National University. Goal: a comprehensive study of the relationship between the number of Ukrainian refugees and Russian attacks on civilian infrastructure and political targets in Ukraine using visualizations methods, time series analysis, correlation analysis, and clustering using is R programming language. 3 datasets were selected for analysis: is the number of Ukrainian refugees abroad, shelling of Ukrainian civilian infrastructure, and shelling of Ukraine's political infrastructure. Since 2022, there has been a significant increase in the number of attacks on political and, even more so, civilian infrastructure. The graph of attacks on political infrastructure also shows that the Russian Federation has been accumulating its resources since mid-2020, as its number of attacks has decreased compared to previous data. The third graph shows the dynamics of the number of Ukrainian refugees, with statistics beginning at the start of the full-scale invasion. 54 and the average of political attacks per month since its beginning of the Russian-Ukrainian war, of which 38 were fatal. 5 civilian attacks per month of average since its beginning of the Russian-Ukrainian war, 4 of which were fatal. Shelling of civilian targets, the moving average smooths out volatile data spikes while maintaining its overall trend. The trend is clearly non-linear, especially after 2022. Shelling of political targets shows more stable activity from 2018 to 2020, with approximately 1,000 events, a slight decrease in 2020-21 is, as in first graph, a sharp increase in 2022. The trend is highly nonlinear, with several distinct phases. The weighted moving average gray line better reflects the dynamics of changes compared to the simple moving average. This smoothing is less aggressive, which allows for better tracking of real changes in the data. In the period 2018 to 21, the trend line reacts more sensitively to data fluctuations. After a sharp jump in 2022, the weighted average adapts more quickly to the new level of activity. Stronger smoothing compared to double equals 3. Better off at filtering out random fluctuations. Greater lag behind actual data. Shows medium-term trends more clearly. Less sensitive to local extremes. The most aggressive smoothing based at identifying long-term trends significantly reduces the impact of outliers. The greatest lag behind actual data, best suited for identifying general trends. Median filtering help smooth out short-term fluctuations and reveal underlying trends in the data. Patterns of shelling of civilian infrastructure indicate that although attacks continue, they have become relatively less lethal. Uh, Fatalities, red line in the political shelling graph, show greater variation but generally lower normalized values. The relations The relationship between events and fatalities is less strong than in the infrastructure dataset. This slide shows how direct smoothing is applied using different window size using the candle method. This slide shows how sequential smoothing with increasing window size is applied using the candle method. All candle correlation graphs show a weak linear relationship, correlation coefficient less than 0.5, coefficient of determination less than 25%, with only the correlation between shelling of political targets and the number of refugees showing a moderate linear relationship. A very strong negative correlation was found between the number of shellings and civilian deaths from shelling, negative 0.806. Deaths from civilian shelling and is the number of Ukrainian refugees, negative 0.868. A very strong positive correlation was also found between the number of incidents and the number of Ukrainian refugees, positive 0.801. Shelling of civilian objects and deaths from civilian shelling, positive 0.893. There is very strong positive autocorrelation, positive 0.969 at leg 1, which gradually is increasing leg. Even at leg 10, autocorrelation remains noticeable, positive 0.628. This indicates a stable trend and inertia in the migration process. The number of refugees in the next period strongly depends on the previous period. The smooth decrease in autocorrelation indicates the relatively stable nature of migration process. The autocorrelation of events decreases more slowly, from positive 0.956 to positive 0.527 at leg 10. The autocorrelation of the number of victims falls much faster, from positive 0.863 to positive 0.16. This means that the shelling itself is more systematic, while its number of victims is more random and less predictable. The number of events shelling shows a rapid decrease in autocorrelation from 2 uh, 2 to positive 0.12 over 10 months, indicating a rather chaotic and less systematic nature of attacks over time. This might indicate that also the attacks themselves are becoming less predictable, their lethality retains a certain systematicity and depends on previous periods. This pattern might indicate a change in attack tactics from regular systematic shelling to more sporadic, irregular attacks, but with similar results in terms of casualties. We applied the same two methods that we used for candle to Poland. Here is method A. And here is method B. As with the candle method, we found weak linear relationships in all correlations except for a moderately strong linear relationship between fatalities caused by shelling of civilian targets and the number of refugees. No new strong correlations that were not detected by Candle's method were detected by Pollard's method. Starting from leg 0, the value gradually decreased to 0.628 at leg 10. This autocorrelation structure indicates the presence of a stable trend in the data. The number of refugees on different days is strongly correlated. This is logical since people usually do not return immediately, but remain abroad for a long period of time. In the graph of civilian shelling, the shelling itself is more systematic and periodic, while its number of casualties is more random and less dependent on previous values. In contrast, in attacks on political infrastructure, the number of casualties is more predictable and systematic than the events themselves. This slide shows how we applied exponential smoothing similar to previous method. And as in previous method, this method reveals a linear relationship of moderate strength only for its correlation between shelling of political targets and the number of refugees. With exponential smoothing, we can see slightly different results in the correlation matrix. There is a very strong correlation between death and shelling, which was not visible before, as well as a correlation between death from shelling and refugees, and a negative correlation between death from civilian shelling and the number of shelling incidents. But at the same time, there is no correlation between deaths from shelling of civilian objects and shelling of civilian objects, or between refugees and shelling of civilian objects. Autocorrelams for exponential smoothing are similar to those obtained for other methods. We also applied two methods for median smoothing. Here we see a result similar to that obtained for the Kendall method, i.e. a linear relationship of moderate strength only between shelling of political targets and the number of refugees. For median smoothing, there is a strong correlation only for deaths resulting from shelling of civilian objects and the number of shellings negative, as well as between its number of Ukrainian refugees and its number of shellings. This smooth, almost linear decline is autocorrelation without sharp jumps indicates the stable nature of the migration process, without sudden changes in trends. The correlation for attacks on civilian infrastructure remains significant throughout the period, with autocorrelation consistently higher for events blue than for casualties red. This indicates the systematic and stable nature of both events and casualties, with events showing more predictable dynamics over time. Attacks on political infrastructure are more random or situation while the number of casualties resulting from them remains more consistent over time. The Kherson region has the highest average number of shellings per month, 14 shellings, while the region that suffered the most attacks per month, 139 attacks, is Kiev. The regions that suffered the fewest attacks are Rivne, Volyn, and Zakarpattia. The pattern is slightly different for political shelling. The Donetsk region suffered the most attacks, with an average of 130 per month and a maximum of 757, while the Zakarpattia region suffered the least with an average of 1.059 attacks per month. This slide shows the proximity matrix for attacks on Ukrainian civilian infrastructure. Kharkiv region most similar to Donetsk 3.44, Sumy 4.26, and Kherson 4.26. Kherson region highest similarity with Kharkiv 4.26, Donetsk 6.68, and Mykolaiv 7.31. Donetsk region highest similarity with Kharkiv 3.44 and Luhansk 6.51. For political shelling, the similarity is slightly different. Kharkiv region instead of Kherson region, and now Luhansk 3.82. Kherson region instead of Kharkiv and Donetsk, and now Zaporizhia and Dnipropetrovsk. Thus, for shelling of political targets, the similarity is based on geographical location, while for civilian targets, it is based on intimidation of the population and the intentions of the Russian Federation towards these regions. The study convincingly demonstrates the systematic nature of Russian aggression aimed at destroying both the civilian and political infrastructure of Ukraine, which has led to large-scale forced migration of the population. Clear patterns and correlations have been identified between the intensity of military operations and the scale of migration, which is critical to understanding the nature of the conflict and its impact on the population. Particular implications of the results. Forecasting migration flows and planning humanitarian assistance, risk assessment for different regions of Ukraine, planning of civil protection measures, development of strategies for the recovery of the affected areas, optimization for humanitarian aid distribution, documentation of Russia war crimes, and improving early warning systems for threats. Thank you for your attention.